ladies and gentlemen. Okay, so this is my D-bit tool and cutter grinder. They have become somewhat popularized of late on the internet. This particular one happens to be made by Grizzly. It's modeled after the Deckel SO tool and cutter grinder. One problem, however, is the wheel holders, the wheel adapters. So here is the wheel adapter, which uses a 20 millimeter bore on the grinding wheels. It also uses a small 5-to-1 taper on the spindle. I have not been able to find these readily available from anyone. For I think the one vendor that I saw that did carry these, they were $175 a piece, which frankly for my amateur machining budget is a little bit on the pricey side. So I did what any good YouTube machinist does, is I went on YouTube and I did a search for these machining of these adapters or similar adapters, and I came up with a few. I already knew that Stefan Gunsfinta had done one. His machinery was actually more precise than I think what mine is in terms of holding centers. So I needed to come up with a way to machine a very precise, both axially and radially, a precise taper, and then hold this bore to that axis, which means these had to be machined at the same time, or at least doing something very true. So I came up with a method, is how I managed to machine a taper on a rough. I roughed it out first, and then I machined the taper, and then I machined an arbor and mounted everything on the arbor and did all the finish work on here. So that's what I'm going to show you today. So to begin with, we're just roughing out our blanks. I'm not exactly sure what steel I'm using here. It was labeled D2 in my box. It's file tested. Fairly hard, certainly harder than mild steel. And I've already back cut the flange because I found that frequently when I'm doing a large diameter thin section like that, I get some distortion during the parting, so I just get a jump on it ahead of time. So that's why it is. You see that parting line in the back. So this is quite oversized because I'll be coming back to resize all of these surfaces after we get the taper board in it. So now we have the original adapter here, and I'm going to use that to set my compound to the taper angle. So we're going to set the indicator up so that as the compound runs in and out, we get no indicated movement. So we're following the taper of the bore pretty much exactly. Now, just in case there is a little bit of axial run out, I do this at a number of points in the bore. I rotate the chuck around and see that I get a zero reading everywhere, because if you've got a little tilt on your chuck teeth, it will come out off. So here's the blank turned around on the taper side, and just to make sure that that chuck tilt is not present. I'm going to give it a little indication. That is a 10,000th indicator, by the way. So a half inch of movement on that dial is a thousandth of an inch. Start our bore. So feel free to click through any of this, and we'll speed this up here. So here we have the tool we're going to be using for boring this taper. I'm using a carbide tool because this steel is it doesn't seem to really like being cut with a high-speed steel. So carbide did a pretty good job, and we want this to be the final cut on this taper. We might do a little polishing on it, but it's not going to get cut again. This is it. So there you go. That should be the final bore. Now, my lathe does not cut metric threads, so this is going to be something on the order of 5/8, 11/16. 20 threads per inch, and or somewhere in there. We'll see what I come up with at the end. Now here's something that I really liked, and I've not seen this. Let me grab my Allen wrench. I have not seen this on any of the other adapters. Normally the screw that holds this wheel adapter on the spindle is in a cap head Allen screw, and it's recessed in a bore. So you take your screw out, and you screw in an 8mm 8x1, I suspect, an 8x1 tool to jack the adapter off the taper. This has a differential jack screw built right into it, and I want to copy that design. I think that's really pretty slick. So this has a 0.5mm thread on a 10mm diameter bolt. So it's 10 by 0.5, which is pretty fine. And it's got a 0.5 thread in here. So for every turn, this is a 6 by 1 here, holding it on. So for every turn of the screw in, you're pulling it in a 0.5 millimeter, because you're losing a 0.5 millimeter on the threaded, where the head threads into the adapter. And so as you back it out, you're doing the same thing. So 1 millimeter of the 6 by 1 minus a 0.5 millimeter for the 10 by 0.5, and eventually you get to the point where it's tight, and you go a little bit more and pop right off of the spindle. So you have your jacking screw built right into the adapter. You don't need to have a separate tool available to pop that off. Each screw that holds the adapter on is also its own jacking screw, which I think is pretty neat, and we're going to copy that as well. And what I've discovered about cutting tapers is that even if you get the taper angle right, you still have to worry about axial and radial run out. And in this case, it's more difficult with a chuck, but in this case you still have this 20-meter section that has to be centered on that taper center, and there's a few ways to do that. So I've done the taper at the same time that I've done my my through holes in the center. So everything from here on is going to be finished cut using that taper as the center. So these are actually going to be mounted on the arbor as they would in the machine while I'm cutting, finishing all the other surfaces, including the bore and thread for that center. Time to drill and tap for our retaining bolt. Okay, time to get this threaded. Well, that was not fun to tap. I actually had to sharpen my tap. If you notice the, see if you see the facet there on the leading edge, the taper, if you will, I reground that by hand. Looking at it on end, I don't know if you can see the angle. I might have overdid one of them there, but as you go up, it's more balanced. Yeah, I just took a stone, a little diamond stone to that, and put it vertically in the vise and put my stone to it at a little bit of an angle, and I had to recut those leading edges because it just wasn't cutting. It just wasn't cutting, and I was afraid I was going to break a tap. So we got it tapped. Now we're going to cut the taper on this, and now I've got my angle set here on my compound, and I've got it set for cutting the taper on the front side with the spindle turning forward. But to keep that angle exactly as it's set and cut the taper on the spindle, I have to cut it on the back side. So that's what we're going to do. We're going to load up one of our cutters, and for this we're going to use a piece of carbide, and this will cut left or right. It's actually cutting the back side with a right hand tool is cutting right handed. So I have a new toy that I made. I'll do a video on this too. It's a very simple centering tool. You draw a straight line, you bisect it with a 90, and you mount your level on there such that it is level, or shows level, when the center of the work is centered on the tool. It's very simple. Works like this. I lay my center on the tool, and I see I'm going to have to drop my tool a little bit. There we go. Drop my tool slightly, and my bubble reads level. Almost. Come on. Okay. Now, I don't know if you can see that level. I'm actually, the level's a little bit, the bubble's a little bit to the right because the lathe is not level. So a little bit to the right is actually on center because the lathe is not level. Backwards rotation. Okay, so the first thing I want to do is I'm going to turn down the head of the jack screw or mounting bolt, however you want to, depending on which way you're turning it, and the thread on the original looks to be about 10 millimeters. Sorry, 9 millimeters. Looks to be about 9 millimeters. And it has a half mil pitch thread. So that works out to pretty much 11/32 by 50 imperial. So I'm going to shoot for that. I'm going to see if I can get down to 11/32 and remove all of the serrations on this. If not, then we'll simply go down to the next size, which would be 3/8. So let's see how we do. I just have a little scrap collar thrown underneath here, since the thread doesn't go all the way in. Okay, so let's see where we are in terms of our dimension. So we're 386, so we're pretty big. All right, so let's shoot for 3/8. 3/8 is the next size down. So let's stick with that. Okay, so I'm all set up here for my threading of this bolt head. It's a 3/8 nominal major diameter, and it's 48 threads per inch. I have my choice between 48 and 52, so I decided to go with 48. And that's a fairly common pitch for number 8 scope mounting screws, if those of you who are into things that go bang. And I got a nice sharp carbide threading tool on there that I just pointed up, and hopefully this will all go well. So let's do our scratch pass and see where we're at. I don't know that I engaged that at the right place. No, I guess I got lucky. So there's our scratch pass. I'll put a little lubricant on that. Let's see what that looks like. No, it doesn't feel bad. Doesn't feel torn. Well, it's a pretty nice looking thread. Well, you can See that? It's not a bad looking thread. I might clean it up a little with a wire brush, brass brush. That's a pretty clean thread. Good enough for the girls I go out with, as they say. Okie dokie. Now comes the tough part. So we're going to clean this up a little. There's our part. And we're actually gonna tighten that sucker on there. Then we're gonna get this out of the way. Now there's plenty of there's plenty of relief in there for going through with a boring tool. And that's pretty tight. I'm gonna have to tap that off with a hammer, hopefully. Because it's just on there, stuck on the taper, jammed in there. But it's a 5-to-1 taper, so it's not real tight. It's not like a Morse taper. Okay. 3/8 48. What's the minor diameter? So it's roughly 15% less than the pitch. So if our pitch is 20.8 times the sine of 60, then our depth of thread radially, not our depth of thread at 60 degrees, but radially, is 18 thou, and 18 thou from both sides is 339.339 inches. So let's see if we can find a drill size that's close to that. Okay, so I've got a Q drill, which looks to be about 330, and I'll just bore it out the remaining 4.5 thousandths to get to 339. So here goes nothing. Put a little lube on that. So that's my initial touch off. So I've got a bore. I've cut that bore all the way around now. And we want a minor diameter of 339. And I'm going to go a little under. It's not going to take much more. Maybe I'll take another pass. Yeah, well, that's there, so I get it. All right, now I need to cut the thread, and to do that, I'm going to need this tool. And it looks like it will just do the job. This is just touching. I'm going to run this at low speed because I'm a chicken, and see what gives here. Now I'm going to be feeding this in radially. I'm not going to use the compound because I'd have to swing the compound around the other way at minus 29.5 degrees to actually do that properly. But it's such a small shallow cut, I don't think it's a big problem. It is a lot of extension on this tool bit. This is meant to do, you know, small inside bores for some distance, but it's what I have. So let's give it a whirl. Nice. Nice.